It's Thursday again. We're back at the museum. Now, it's extremely windy, so I apologise for the noise. The question is, will the beast be free from its cage today? And that's a slightly poetic way of saying, will it be able to get the engine out of its nacelle? Let's find out. Right, so you can see there, I've managed to turn the engine over more or less onto its back, and it's underneath a piece of foam, just to protect it. It's much easier to get to the bolts I need to get to in this orientation and to saw them as well. So I'll show you what the problem is. So you can see down there, look. Can you see that bolt head? What I've got to do is get the saw in that gap between that intake there, which is the blower intake, and cut through the threaded portion of the bolt, because I've only been able to unthread it, well, approximately, I would say about between 3 and 5 mil, give or take, with the washer. That one's out. That one there that you can see there, I've just sawn through that one. So I'll continue now and saw through that one. Then there's another one like that on the other side, and similarly that one's brother on the other side as well. So I'll get on with that now, and I'll bring you back hopefully with some progress. Right, so that bolt you can see there, that one is the last one that I've got to saw through, and then the engine should slide out of the nacelle towards me, towards the direction of the camera. So I'll crack on with cutting through that, and I'll bring you back for the great moment. So I've got to undo this one a little bit to get the saw in, and you can see by what I'm filming now that this is the kind of access you've got. And yeah, this type of thing was very common on my time working on British aircraft, and all aircraft actually, not just British, but I primarily worked on British aircraft. But this is pretty much standard. Right, let's see if we can get the saw blade in there now. But the much vaunted power saw that I brought with me was of no use to man a beast because the battery died. So I shall have to have a look at that, possibly with some warranty claim. But anyway, we'll see. I'm going to open that up a bit more, I think. I'll bring you back. Hopefully you can see the head of that bolt is slightly skewed, and that's because I've just cut through it. The last one has gone. I think it's the last one. Well, I know it's the last one. And whoever put this together back in the mists of time when I was but a nipper, they must have used bolts of different materials, because some bolts were tougher than others, and some bolts' mothers are tougher than other bolts' mothers. But anyway, enough of that. We're going to get this out of its nacelle now. This is it, the big moment. I think it just needs a good dunt, as they would say in these parts. The question is, have I got a big enough hammer? It's stuck, and I can see where it's stuck. Right, here we go. through the light line this side and have a look. It's nearly out. It's so close now. Oh, so the issue I've got is the mercury boiler. The pillory tube is jammed between the bottom of the gearbox and the nacelle, and I really don't want that to happen, because I don't want that mercury boiler tube to get damaged. So what I think I'll do is I will tip this over like that, as much as I dare, and then try and pull the nacelle this way. It's got stuck. Oh, no, we don't want that to happen. Yeah, you can really see the angle of it now. You know what, I think I'm going to sit this down on the face of the turbine. I don't see any reason why I can't do that. I'll just bang that pipe out of the way for the time being. I think that's going to be the safest way to do this. Right, come on here. So much for pictures of people. So there it is. That's what I forgot. That. So let's get that off, and then she'll be out. It's out! I know! So one of the lights I was using has just died a death. I've now had a cup of tea, which was most welcome. And we had a run round of the engine when it was in the nacelle, when we first came here, when Harry and I first took the jet pipe off and we first started working on it. But now it's out, let's have another one because it's a lot easier to see now. So this is the jet pipe end, and if you look inside there, you can see the turbine. And if I pull the light just right, you can see that it turns. So that bodes really well. And the blades don't look as if they're in too bad condition. There's no big chunks out of them at any rate. Oh, the wind noise is horrendous. There's a feather there, look, from when there was a bird living in here. But the bird doesn't seem to have done it any harm anyway. Here we've got the thermocouples for the jet pipe temperature. And there's the mercury boiler sensor. And what that does is, that communicates with the temperature control unit on the fuel pump. And it backs off the fuel if the turbine gas temperature gets too high. So, moving around. Down here we've got the drain tray. And that big block in the center there, that's a fuel drain. And then that sort of cylindrical item there is the oil filter. And this aluminium casting here, that's sort of T-shaped, more or less, that's the compressor housing, and the bottom of which is the sump. And this here is the sump heater. The reason it has to have a sump heater is because at altitude. This is in an unpressurized part of the aircraft, so it could be very cold in there. You know, it's a bit parky at the best of times at 20,000 feet. So essentially what this does is it maintains the oil at a temperature which keeps its viscosity within limits, so that if the APU has to be started in flight, then it's not full of treacle in the bottom of there, it's full of oil at the correct viscosity. Now the oil that this uses is OX38, and it's a good quality general purpose synthetic oil, which is recommended for use in turbine systems, turbo shaft engines essentially, where there's a gearbox involved, so it's just good for general lubrication of bearings and gears as well. Here's one of the bolts, look, that I sawed through. Might keep that as a sort of a little memento of removing it from the nacelle. Anyway, we'll move around. There's part of the intake trunking, and that runs up to the center, or to the top rather, of the, you can see just in there, look, you can see it, of the compressor intake at the middle of the compressor housing. And we'll come round. Here's the plenum for the compressor outlet, and inside that is the plenum for the turbine inlet. Here's the combustion chamber with the igniter plug. This part here is the top of the compressor casing. There's the compressor impeller, will be inside there, and this ring of bolts. That's the igniter plug, as I've said. This is the top part of the intake trunking. So this is the actual intake of the compressor here and here. That's the oil breather, which has a special valve inside that so that it doesn't basically chuck all the oil out if the aircraft goes inverted. And that goes over there into the cyclone separator, which we'll talk about in a minute. Nice bit of fabrication, actually, that cyclone separator. Right, so single combustion chamber. Inside here, this is the outer casing. Inside there is the flame tube, which has various holes drilled in it that we've talked about before on my channel in terms of how a gas turbine combustion chamber works. Here is the injector block. So on the other end of this flange, there is a sleeve, inside of which there is a swirl adapter, or a swirler essentially, just a piece of material that's got a kind of a helix cut into it, almost like a coarse thread. And as the fuel runs through that, it causes it to have a tangential velocity, so that when it comes out of the end of the injector, it comes out in a cone-shaped fan, and that causes it to break into very fine droplets. Here we've got the connection coming in from the fuel pump. Here we've got the connection coming in from the fuel drain, so out rather, so that's the fuel drain. This one here is from the air pump and also from the outlet of the compressor, so that when the engine's running, we've got air assisted atomization from the compressor air, and when the engine is initially starting, we have assistance from the air pump, which we tested in the previous video. So what that does is when it goes into there, it runs into what's called an emulsion block, which is almost like a venturi essentially, so that the fuel, as it's passing through the venturi, it entrains air in with it, so that as it starts to go through the swirl adapter in there, it's got bubbles in it. And also some of that air goes through a shroud around the outside of the swirl outlet that helps to break the fuel up as well. With having bubbles in it, when it comes out at the end of the swirler, the bubbles want to expand, and they basically assist the breakup. So a very prominent component on this injector block is this actuator. So this is a Rotax rotary actuator. So what that does is, when the signal or a voltage goes on one pin inside the breeze connector here, so there's 3 pins, a ground, 1 and 2. So when it goes into 1, the thing rotates clockwise. When it goes into 2, it rotates anti-clockwise, and it rotates through 90 degrees. There'll be a little Oldham's coupling in there. that's driving a valve in here which opens or closes a valve to allow the fuel to enter the injection side or to stop it from entering. So this is basically like your HP cock. HP cock in aircraft parlance means the main valve that switches your fuel on and off. And the reason they have this is to prevent dribble from the injector, which might just cause a run-on of the engine. So that's what that does. Here we've got the front face of the gearbox, which we've seen quite a lot of. Here's the fuel pump with its attendant high temperature control unit underneath. So there is the line, the capillary line from the mercury boiler, which runs into the high temperature control unit. So inside here there is a Borden tube essentially, and what that does is it controls the spill valve. So as the temperature of the engine increases, if it goes beyond a certain point, that spill valve starts to spill back to the gallery, and what that does is it backs off the engine speed as the jet pipe temperature increases. So this is really the overspeed control, if you like. We're using temperature of the outlet of the turbine to gauge how fast it's running. And that there is a little check valve. This is for inhibiting the fuel system, so that runs through into the fuel system, so we can inhibit it if we need to. With usually it's oil that is inhibited with OM11, which is just a general mineral low viscosity lubricating oil, a bit like 3-in-1. So on the back of this fuel pump, inside the gearbox, you can't see it, but this is driven from a quill shaft in the gearbox, this fuel pump, and on the back of the fuel pump is the gear oil pump, which supplies lubricating oil to all the bearings, the turbine bearings and all the gearbox bearings. So inside here there is a triple reciprocating piston pump. So basically it's a swash plate pump, and there also is a centrifugal governor system in there that's quite clever, and I'll show you that in the AP in the diagram. So we'll move back around the other side now of the engine. Actually, let's follow this pipe, because this is the air pipe coming from the air pump and the compressor into the injector block. So that runs up. You can see there, look, silver soldered on is the pipe ident. Runs up from the injector block into this T-piece where it's silver soldered in, or perhaps even TIG welded. This line here goes down to the drain tray, and there's a little Schrader valve under there that's used for testing the output of the air pump. So that's a test point. We then come over to here, look, and you can see, look, how that's been welded, like I told you about, into this T-piece, which incorporates a check valve. So this line runs down, comes down here and goes to our air pump, or it would do if we hadn't taken the air pump off. This side runs around down here and into the air plenum from the compressor. So we're taking some air from the compressor, we're bleeding it off and using that to assist atomization, and it does that all the time the engine's running, and when it starts it uses the air pump as we've already discussed. There's another couple of thermocouples, look, for the jet pipe temperature. That's where we cut the loom coming out of those breeze plugs that were seized up. That terminal block there is the cold junction terminal block for the thermocouples. There's another view of the drain tray there. That's the plug that we took off, the Bendix plug that came off the air pump. This sheet metal bracket here is where the air pump was mounted. Firewire, and this is a firewire connector. Look, firewire is a system of, basically there's inside here there's a thin wire surrounded by a ceramic filler, and it acts as a heat sensor, basically like a thermistor essentially, and that is connected into a special bulkhead, which then goes to a control unit. Firewire is used on almost all aircraft, not just British aircraft. This is the compressor washing connection, and that you use essentially a mixture of kerosene, something called Turbex, I think it was called, which is like a solvent, and distilled water, and you force it through there, do a dry cycle on the engine, and it runs through the compressor, the combustion chamber, turbine, and it's just intended to clean out any carbon deposits that might have built up over time. Here's the other side intake, trunking going into the compressor housing. And I don't know if you can see, yeah, you can almost see. Let me see if I can show you it. Get the light in there properly. Maybe I swap the light round. You can almost see the impeller if I just get the angle right. Not quite. Right. So here's the intake trunking for the blower that caused us so many problems. And I don't know if I've done that there. Can you see that? I don't know if I have. Perhaps I have. Yeah, looks quite new, doesn't it? But anyway, no harm done. It's out now, and that's the main thing. So that's a general run round of the engine. Oh, we forgot about the old cyclone separator, didn't we? So this uses air from the compressor basically to separate oil out from the air that's the turbine gases, if there's any oil in them, and that goes to the drain trap. So I'm outside now out of that swine of a rub hanger, so we've got to now try and remove as much as I can from this nacelle. So the LP fuel filter rather, is the main thing that's going to come off. And then inside the hoses, these Lockheed Avery connectors here. We'll try and get the breeze plug off that we had to cut, and we'll get all these breeze plugs out as well, and the bulkheads for the firewire connectors. So we'll do that now. GS banjo. We'll find out exactly what one it is later on, but it requires a 7/16 BSF spanner to undo it, and also a 1/2" BSF spanner on that one. So these are Lockheed Avery couplings, hydraulic couplings, self-sealing. So we'll recover them. And I'll show you another example of them in a minute. So that's what the other side of a Lockheed Avery coupling looks like. Note that one, the drain, is stuck up. Now I suspect those hoses have seen better days. But now we'll get these ones off from underneath, and then we can get these 6BA bolts out and get these off. As promised, look, there's your other Avery Lockheed connectors on the side of a jet provost. There you go. Very common on British aircraft. So I'm now taking off all these 4BA bolts to take these Avery Lockheed or Lockheed Avery connectors off. So I still can't get that darn breeze plug undone, but no matter, not too worried about them. What I am going to do though is recover these two firewire connectors, and they are 2BA rather. And we'll get that bulkhead there as well. So that's the end of Rover Gas Turbine number 5. We're back in the workshop now. So the next one that you watch will be us putting the engine, or bringing the engine into here from the museum. So that should be a fairly eventful one, let's put it that way. So if you've enjoyed the video, please give me a like. I could do with a lot more likes. That would be wonderful, and it really does help me to grow the channel. And the YouTube algorithm will seep me through into other people's feeds, and we'll start to see the channel gaining a few more subscribers, which would be nice. I'd like that. If you're not subscribed, please do so. That'd be great as well. I'd love to have you along with this journey with the engine, and also with the milling machine as well. Let's not forget about that. How could I? So see you next time, people. Take care of yourselves, and thank you very much again for all your support.